Assalamu alaikum. I'm Dr. Wael Muhammad, PhD in Applied Mathematics from Egypt for EDEXCEL AS Level Pure Math 1. In this video, we'll solve classified past papers of Chapter 5, which is Coordinated Geometry, Straight Line Graphs. For Chapter Review 5, question number 1, the straight line passing through the point P to 1 and the point Q, K and 11 has gradient -5/12. Find the equation of the line in terms of x and y only. Piece of cake, of course, right? We can apply the y minus y1 over x minus x1 is equal to m, which means that y minus 1 over x minus 2 is equal to -5/12, right? Keep y minus 1 as it is and multiply -5/12 times x minus 2, so it will be -5/12 times x, and then negative times negative will be positive. We can simplify 2 with 12 here to be 1 over 6 times 5 to be 5 over 6. Finally, move -1 to the right hand side with +1, so the answer should be y equals -5/12 x, and then +5/6 plus 1, which is +6/6. 6 plus 5 will be 11/6. This is the answer, okay? B. Determine the value of k. We have two methods to get the value of k. We can use our result here and substitute x with k and y with 11, and then we can get the value of k, or we can say y2 minus y1 over x2 minus x1 is also m, right? So I prefer this method here. y2, which is 11, minus y1, which is 1, to be 10. 11 minus 1 is 10, divided by k minus 2 is equal to -5/12. Make cross multiplication. We have -5k plus 10, which is -5 times -2, equals 120. 12 times 10. And then moving 10 here, we have -5k equals 110. By dividing by -5k will be -22. Okay. Question 2. The points A and B have coordinates k and 1 and 8 and 2k minus 1 respectively, where k is a constant. Given that the gradient of AB is 1/3, show that k equals to, okay, piece of cake, of course. We can apply y2 minus y1 over x2 minus x1 is equal to m. y2 here is 2k minus 1 and then minus 1. 2k minus 1 and then minus 1. So we can write -2 over 8 minus k is equal to the gradient, which is 1/3, right? Make cross multiplication. It will be 6k minus 6. 6k minus 6 is equal to 8 minus k. And then solving for k, -k plus 6k will be 7k. And then 8 plus 6 is 14, which means that k equals 2, as the question said. The second item here is find an equation for the line through A and B. Okay, in this case, A, after replacing k with 2, will be 2 and 1, right? And also B will be 8 and 2 times 2, 4 minus 1, 3, 8 and 3. And now we will get an equation by knowing these 2 points. So we can apply this rule here, okay? Y minus y1, which means y minus 1 over x minus 2 is equal to 3 minus 1, which is 2, divided by 8 minus 2, which is 6, which can be simplified to be 1/3, right? And then make cross multiplication. We can find here x minus 2 is equal to 3y minus 3, or we can write x minus 3y, positive 3 minus 2 will be positive 1 equals 0, okay? 3. The line L1 has gradient 1/7 and passes through the points A2 and 2, and the line L2 has gradient -1 and passes through the point B4 and 8. The lines L1 and L2 intersect at the point C. Find an equation of L1 and equation for L2. Okay, very nice question. For L1, we have here y minus y1 over x minus x1 is equal to m1, which is y minus 2 over x minus 2 equals 1/7. And then making cross multiplication, we have x minus 2 equals 7y minus 14, right? So we can write here x minus 7 y is equal to 2 minus 14, which is negative 12. This is the first equation. For L2, applying the same formula, we have here y minus 8 divided by x minus 4 is equal to negative 1, which means negative x plus 4, negative x plus 4 is equal to y minus 8, or we can rearrange the equation to be x plus y is equal to what? Is equal to 4 plus 8, which is 12. This is the second equation. B, determine the coordinates of C, which is the point of intersection. We can solve these equations simultaneously. We can say equation 2 minus equation 1 to write the following. X minus x will be cancelled. Y minus 7y, which means 8y is equal to 12 minus 12, which is 12 plus 12, 24. In this case, dividing by 8, y should be 3. Substituting the second equation, because it's easier, we can find x to be 12 minus 3, which is 9. So the coordinates of C should be 9 and 3. Very easy. Question 4a, find an equation of the line L which passes through the points A, 1 and 0 and B, 5 and 6. Very nice question. We can apply in this formula y minus y1, which is 0, okay, divided by x minus 1 is equal to y2, which is 6 minus y1, 0. 6 minus 0 is 6, divided by 5 minus 1, which is 4, which can be simplified to 3 over 2, right? And then make cross multiplication. We have here 2y is equal to 3x minus 3, or we can write it as 3x minus 2y equals 3. This is the first equation, okay? The line M with equation 2x plus 3y equals 15 meets L at the point C. Find the coordinates of C. Very good. The second equation, which is 2x plus 3y equals 15, we want to solve these two equations simultaneously, right? I'll focus on cancelling y, because y here with positive coefficient and y here with negative coefficient. So multiplying equation 1 by 3 gives us 9x minus 6y is equal to 9. And equation 2 times 2 will be 4x, and then plus 6y is equal to 15 times 2, which is 30. And then we can solve these two equations simultaneously by adding directly. I will add to get 9x plus 4x, which is 13x, 6y minus 6y will be cancelled, and then equals 39, which means that x equals 3. Substituting with x in the second equation, you can write 3y equals 15 minus 2 times 3, which is 6. 15 minus 6 is 9. In this case, y is 3 also, right? So the point of the section will be 3 and 3. 6. The straight line L1 passes through the points A and B with coordinates 2 and 2 and 6 and 0, respectively. Find an equation of L1. Piece of cake, of course, right? Applying in this formula, we have y minus 0, it will be y over x minus 6 is equal to 0 minus 2, which is negative 2, divided by 6 minus 2, which is 4, which can be simplified to be negative half. Making cross multiplication, you can write 2y and then equal negative x plus 6, right? Negative x plus 6. Or we can write x plus 2y equals 6. If you want to check this answer, you can substitute x and y with 6 and 0, right? If y equals 0, then x equals 6. Very good. And also if x equals 2 and y equals 2, 2 plus 4 is 6. Very nice. The second part here, the straight line L2 passes through the point C with coordinates negative 9 and 0 and has gradient 1/4. Find the equation of L2. Applying this formula, we have y minus 0 here will be y over x minus 9 to be x plus 9 is equal to 1 over 4. And then making cross multiplication, we have 4y equals x plus 9, or we can write it as x minus 4y plus 9 equals 0, right? 7. The straight line L passes through 1 and 3 root 3 and B 2 plus root 3, 3 plus 4 root 3. Show that L meets the x-axis at the point C, negative 2 and 0. Very nice question. Our strategy here is to find the equation of this line L and then put y equals 0 to show that x should be negative 2. Okay, so applying on this formula, we have y minus y1, y minus 3 root 3 over x minus 1 is equal to 3 plus 4 root 3 minus 3 root 3 divided by 2 plus root 3 minus 1, which can be simplified to be 4 root 3 minus 3 root 3, just 1 root 3. 3 plus root 3, and here 2 minus 1 will be 1 plus root 3. Let's rationalize this fraction. I will multiply both numerator and denominator by 1 minus root 3, and here also 1 minus root 3. In this case, the denominator should be 1 minus 3. And for the numerator, we multiply 3 times 1, 3. 3 times negative root 3 would be minus 3 root 3. And then root 3 times 1 plus root 3. And then root 3 times negative root 3 would be minus 3. So we have here in the denominator minus 2. In the numerator, 3 minus 3 will be cancelled, and negative 3 root 3 plus root 3 will be negative 2 root 3, which can be simplified to just root 3, right? So we can say y minus 3 root 3 over x minus 1 equals root 3. We can make cross multiplication now to get y minus 3 root 3 is equal to root 3 times x minus 1 to be root 3x and then minus root 3. This is the equation, which can be simplified to be y equals root 3x and then minus root 3 plus 3 root 3 plus 2 root 3. Right? Now, if we put y equals 0, we will find that root 3x equals negative 2 root 3, which can be simplified by dividing by root 3 to show that really x is equal to negative 2 as the question said. Question 8. The points A and B have coordinates negative 4 and 6 and 2 and 8 respectively. Line P is drawn through B perpendicular to the line AB to meet the y-axis at point C. Find an equation of the line P. Very nice question. Now, M for the line AB will be y2 minus y1 over x minus x1 to be 8 minus 6, which is 2, divided by 2 minus minus 4, which is 6, which can be simplified to 1 over 3, right? Now, to get M to the perpendicular line, it will be negative 3, right? Change the sign and flip the fraction upside down. Now we have the gradient of the perpendicular and we have a point which is B, so we can write y minus y1 over x minus x1 equal the gradient of the perpendicular to be y minus 8 divided by x minus 2 is equal to negative 3, and then we can simplify it to be y minus 8 is equal to negative 3x plus 6, or y plus 3x equals 6 plus 8, which is 14, right? B, determine the coordinates of point C. Okay, to get C, which is the y-intercept, put x equals 0 to get y equals 14. So C equals 0 and 14. Question 9. The line L has equation to x minus y minus 1 equals 0. The line M passes through the point A, 0 and 4, and it's perpendicular to the line L. Find an equation of M. Very good. First of all, we must put the equation of L in the form y equal mx plus c to be positive y equals 2x minus 1, so that the gradient of L should be 2, right? And directly the gradient of the perpendicular line will be negative 1 over 2. So this is the gradient of m, and also we have the y-intercept, which is 4. This is the y-intercept. So directly we can say that for the line m, y equals -1/2x plus 4. B, show that the lines L and M intersect at point P with coordinates 2 and 3. Very good. Here y equals and here y equals, so we can equate the two y's together to be 2x minus 1 equals -half x plus 4. Collecting x together, we have 2x plus half x to be 5/2x equals 4 plus 1, which is 5. In this case, 5 cancel 5 and x equals 2, as the question said here, x is 2. And put it in the first equation, maybe easier. In this case, 2 times 2, 4. Y equals 4 minus 1. Y equals 4 minus 1, which is 3. So the point of intersection is 2 and 3. Exactly, right? The line N passes through the point 3 and 0, okay, and is parallel to the line M. Find the coordinates of the point of intersection of the lines L and N. Okay, let's find the equation of N at first. We have for line N, we have the same gradient of the perpendicular line, which is -half, and we have the point which is 3 and 0, right? Y minus 0 over x minus 3 is equal to -half, and then we can write 2y equals -x plus 3. The required now is to solve this equation with the equation of L, the first one, which is y equals to x minus 1. Y equals to x minus 1. Maybe the easiest way is to say 2y means double of this, right? Double of this side. So we can write 4x minus 2 equals to y here, which is -x plus 3. Collect x together. 4x plus x, 5x is equal to 3 plus 2, which is 5. This means that x equals 1, and directly we can find the corresponding value of y from here. 2 times 1 is 2, minus 1 is also 1. So the point intersection will be 1 and 1, okay? Question 10, the line L1 passes through the points A and B with coordinates 0 and -2 and 6 and 7. Respectively. The line L2 has equation x plus y equals 8 and cuts the y-axis at the point C. The line L1 and L2 intersect at D. Find the area of triangle ACD. Of course, first of all, we must get the coordinates of D, right? So we must get the equation of L1. For L1, according to this formula, y minus 2 will be y plus 2 over x minus 0 to be x is equal to 7 minus minus 2, which is 9, divided by 6 minus 0, which is 6, which can be simplified to 3 over 2, and then we can write 3x is equal to 2y plus 4, or we can write 3x minus 2y equals 4. The required now is to solve this equation with x plus y equals 8. Okay, I will multiply this equation by 2 to be 2x plus 2y equals 16. Okay, and I call it number 2 and this is number 1. By adding 1 and 2, adding 1 and 2, we can get the following: 3x plus 2x, we have 5x. 2y minus 2y will be cancelled, and 4 plus 16 will be 20, and in this case x should be 4. We can say, of course, since x plus y equals 8, y also should be 4. So the coordinates of D is 4 and 4. Now to get the area of triangle ACD, we want to know the coordinates of A, which is 0 and -2, and coordinate of D, which is 4 and 4. Finally, coordinates of C, y-intercept of the line x plus y equals 8, which is of course 8. 0 and 8, I mean 0 and 8. Very good. So we have from, if we imagine this triangle, we have from above here 0 and 8, and from below here we have -2, and then 4 and 4, like this. Okay, right? So Of course, we will apply the rule half base times height. This is the height, and this is the base. The base with length 10, 8 above and 2 below. So the area of this triangle will be half times 10 times the height, which is 4, of course, to be 20 square unit. Okay. Question 12, the points A, -1 and -2, B, 7 and 2, and C, K and 4, where K is a constant, are the vertices of triangle ABC. Angle ABC is right angle, very important given. B is right angle means that AB is perpendicular to BC. Find the gradient of AB. It's very easy, of course, because the gradient of AB is equal to y2 minus y1, which is 2 minus minus 2, 4, over 7 minus minus 1, which is 8. It will be half. B, calculate the value of K. Very good. Now we have the gradient of AB, right? What about the gradient of BC? According to this information, of course, it will be -2. So use this to find the value of K. Now the gradient of BC is known, and also we have the coordinates of C and the coordinate of B. So we can say 4 minus 2, 4 minus 2 to be 2, and then K minus 7 is also -2. And then we can make cross multiplication, okay, to be -2K plus 14 is equal to 2. And then we can say 2 minus 14, -12. Divide both sides by -2, K should be 6. Right? C, find an equation with a straight line passing through B and C. Okay, we have a given point B and we have the gradient, which is -2. So we can write the following: y minus y1, which is 2, divided by x minus 7 is equal to -2. And then y minus 2 is equal to -2x plus 14, -2x plus 14, or we can write y plus 2x equals 14 plus 2, which is 16. And since the required is to find the equation in the form ax plus by plus c equals 0, we can write it as positive 2x at first, and then plus y minus 2 minus 14, which is minus 16, equals 0. A here is 2, B is 1, and C is -16. D, calculate the area of triangle ABC. These are the coordinates of A, B, and C, and don't forget that AB is perpendicular to BC, so we can apply the rule half base times height, considering AB as a base and BC as a height, okay? So we should get the distance of AB, which is square root of x2 minus x1 all squared plus y2 minus y1 all squared. 2 minus minus 2 will be 4 squared. We can start with x or y, it will not differ, okay? 16 plus 7 minus minus 1, which is 8 squared, 64, to be square root of 80. And also we can find the distance BC, which is a square root of difference of x squares. 6 minus 7, -1, all squared will be 1, plus 4 minus 2, 2 squared will be 4, to be root 5. And then we can write area of the triangle will be half base root 5 times root 80 can be written as root 16 times 5, which is 4 root 5, right? 4 root 5. In this case, half 4 is 2, root 5 times root 5 is 5, so it will be 10 square units. 13a, find an equation of the straight line passing through the points with coordinates -1 and 5 and 4 and -2, giving your answer in the form ax plus by plus c equals 0. Very nice question. Applying on this formula, we can write y minus 5 over y minus 5 over x minus minus 1 to be x plus 1 is equal to 5 minus minus 2 to be 7 over -1 minus 4 to be minus 5, and then making cross multiplication we have 7x plus 7 is equal to -5y plus 25. Arrange the equation according to the required to be 7x, and then plus 5y plus 7 minus 25 to be minus 18. is equal to 0. The line crosses the x-axis at point A and the y-axis at the point B and with the origin. Find the area of triangle AOB. Very good. We should get the coordinates of A. A is what? The point is of intersection with x-axis, so y should be 0. If we put y equals 0 here, then 7x equals 18, which means that x equals positive 18 over 7. And for point B, B is the point of intersection with y-axis, which means that x is 0. If we put x equals 0, in this case 5y equals 18, which means that y equals 18 over 5. Now we have right angle triangle like this. This is A and this is B and this is the origin, so the area should be half base times height. The area should be half base, which is 18 over 7 multiplied by height, which is 18 over 5, and the answer should be 162 divided by 35. 14. The straight line L1 has equation 4y plus x equals 0. The straight line L2 has equation y equals to x minus 3. On the same axes, sketch the graphs of L1 and L2. Show clearly the coordinates of all points at which the graphs meet the coordinate axes. For the L1, we can write the equation as 4y equal minus x, which means that the line passes through the origin, of course, if x equals 0, y equals 0. And if we put x equals 4, then y should be what? 4y equals minus 4, which means by dividing by 4. So this is the first line. For L2, we have y equals to x minus 3. So if x equals 0, y equals minus 3. And now try to get if y equals 0. If y equals 0, then to x equals 3, which means that x equals 3 over 2. This is L2, and these are the 2 points of intersection with the coordinate axes. Then the lines L1 and L2 intersect at the point A. This is A, of course, and they're required to get the coordinates of A as exact fractions. Okay, we'll solve them simultaneously, right? 4 times y, this is y. 4 times 2x minus 3 is equal to minus x, which is 8x minus 12 is equal to minus x. Moving negative x to the left to be 9x is equal to 12. In this case, x easily will be 12 over 9, which can be simplified to be over 3, 4 over 3, 3. And in this case, we can find the value of y, because 4y equals minus x, which is minus 4 over 3. We can cancel this 4 to find y to be minus 1 over 3. So the coordinates of A should be 4 over 3 and negative 1 over 3. C. Find an equation of the line through A which is perpendicular to L1 in the form x plus b plus c equals 0. The gradient of L1 is minus 1 over 4, right? And so that the gradient of the required line now, which is the perpendicular, should be positive 4. And so that y minus y1, which is negative 1 over 3, plus 1 over 3, over x minus x1, which is 4 over 3, is equal to what? Is equal to 4. Cross multiplication, so we have here y plus 1/3 is equal to 4x minus 16 over 3. Multiplying all equation by 3, so we can get what? We can get 3 times 4x will be 12x, and then 3 times y will be 3y, and the negative sign, minus 3y. When we multiply this by 3, it will be 16, and this by 3, it will be 1. So it will be minus 16 minus 1, which is minus 17, equals 15. The points A and B have coordinates 4 and 6, and 12 and 2, respectively. The straight line L1 passes through A and B. Find an equation of L1 in the form ax plus b plus c equals 0. A, B, and C are integers. Very nice question, and we solve many questions like this. So you'll apply in the formula. So we can write y minus 6k over x minus 4 is equal to 2 minus 6, which is negative 4, divided by 12 minus 4, which is 8, which can be simplified to negative half. And then we can write 2y minus 12, 2y minus 12 is equal to negative x plus 4, or as the question required, we can write x plus 2y minus 12 minus 4 minus 16 is equal to 0. Okay, the straight line L2 passes through the origin, okay, and has gradient negative 2 over 3. Write down an equation of L2. Of course, for L2 we can write y equals just mx because you don't have y-intercept now. So it will be y equals the gradient, which is negative 2 over 3 times x. Just like this. The lines L1 and L2 intersect at the point C. Find the coordinates of C. Very good. We can solve them simultaneously as the following. We can substitute y with this. So we can write x plus 2 times y, which means negative 2 times 2, negative 4 over 3x is equal to 16. X minus 4 over 3 will be negative 1/3 is equal to 16, which means that x is equal to negative 48. And then y will be negative 2 over 3 times negative 48. To be negative 48 divided by negative 3 will be positive 16 times 2, it will be 30. So the coordinates of C should be negative 48 and 32. D, show that the lines OA and OC are perpendicular where O is the origin. Okay, the gradient of OA is y2, 1, x1, y1 can be 0 and 0, the origin, okay? So it's 6 over 4, which is 3 over 2. And the gradient of OC will be 32 over minus 48, which can be simplified by dividing by 16, it will be 2, and by 16 negative 3, or we can say negative 2 over 3, which show that OA is perpendicular to OC, of course. The product is negative 1, okay? E, work out the lengths of OA and OC, write your answer in the form K 13, and finally find the area of triangle OAC. To get the length of OA, it will be square root of 4 squared, which is 16, plus 6 squared, which is 36, and it will be square root of 52, which can be simplified to 2 root 13. And to get the length of OC, we can say square root of 48 squared, because the negative square is positive, okay? And then plus 32 squared, and the answer can be written as 16 root 13. And finally, to get the area, we can say the area is half base times height, half times 2 root 13 times 16 root 13, which is 208 square units. 17. A is the point negative 1 and 5. Let x and y be any point on the line y equals 3x. A, write an equation in terms of x and x for the distance between x and y and a negative 1 and 5. For A, the required is to get the distance between A and any point. I name it P. The coordinates of A is negative 1 and 5. The coordinates of P is x and y. I replace y with 3x. And then to get AP, it will be square root of difference of x squared. It will be x minus minus 1, which is x plus 1 all squared. And then 3x minus 5 plus 3x minus 5 all squared. Okay? Expanding x plus 1 all squared will give us first squared, and then 2 times first times second, plus 2x, plus second squared, which is 1. And expanding 3x minus 5 all squared will give us 3x all squared, 9x squared, and then 2 times first times second, it will be minus 10 times 3 minus 30x, and finally plus 25. Add them together to get AP, or we can write AP squared will be x squared plus 9x squared, 10x squared, and then 2x minus 30x minus 28x, and finally plus 25 plus 1 plus 26. Find the coordinates of the 2 points B and C on the line y equals 3x, which are a distance of square root of 74 from negative 1 over 5. Now the distance is given, root 74. So for item B we can write 10x squared minus 28x plus 26 is already 74 because we are squaring them together. Simplifying by dividing by 2, we can get this quadratic equation. By factorizing it, we can get x minus 4 times 5x plus 6. So x can be 4 or x can be minus 6 over 5. And as y equal 3x, in this case y will be 12, and in this case y will be minus 18 over 5. So the required points can be 4 and 12, or negative 6 over 5 and negative 18 over 5. C. Find the equation of the line L1 that is perpendicular to y equal 3x, okay, and goes through the points negative 1 and 5. Very good. To answer part C, we have the gradient of the given line is 3, and so that the gradient of the perpendicular line is negative 1 over 3. And then y minus y1, which is 5, over x minus x1, which is x plus 1, is equal to negative 1 over 3. And by cross multiplication, we have here 3y minus 15 is equal to minus x minus 1, or we can arrange it to be x plus 3y minus 15 plus 1, which is minus 14, is equal to 0. D. Find the coordinates of the point of intersection between L1 and y equal 3x. We can solve this equation and y equal 3x simultaneously. So I can write x plus 3 times 3x. It will be 9x equals 14 here. And so that 10x equals x equals 1.4. So y equals 4.2, and the point of the section will be 1.4 and 4.2. E. Find the area of triangle ABC. This is the situation now, okay? I draw the triangle. This is A, negative 1 and 5. These are B and C. Whatever, where is B and where is C? We have one of them 4 and 12, and the other is negative 6 over 5 and negative 18 over 5, okay? But what we know that this distance is the same as this distance, both of them is square root of 74, right? And also we know that this is perpendicular, and this point is 1.4 and 4.2, which is the point of intersection. So we can say half base times height. I will say this is the half base, okay, and this is the height. So I will use the distance formula to find the distance between these 2 points as the half of the base, okay, because this distance is the same as this distance. And also I will use the distance formula to find this distance to be the height. And in this case, the area will be square root of 4 minus 1.4, okay, which is 2.6 squared, plus 12 minus 4.2, which is 7.8 squared. This is half of the base times height, which is square root of the distance here, which is negative 1, negative 1.4, which is negative 2.4 squared, 2.4 squared, plus 5 minus 4.2, which is 0.8 squared. By calculating this, the area should be 20.8 squared unit. This question is from exercise 5F. The points A and C on the y-axis and the point B lies on the x-axis. The line through points A and B is perpendicular to the line through B and C. They are perpendicular. Find the value of C small here. The gradient of AB should be the vertical over the horizontal, which is 4 over 3. And so that, of course, the gradient of BC, which is perpendicular to it, is minus 3 over 4. This minus 3 over 4 can be written as y minus y1 over x minus x1 here, the equation of this line. So y minus 0 is y over x minus 3, it will be x plus 3. And so that y as negative 3 over 4x minus 9 over 4. According to the formula y equal mx plus c, this is the y-intercept. So c small is negative 9 over 4. The points A, B, and C, where k is a constant, lie in the same straight line. Find the possible values of k. Any 2 points of them have the same gradient. M, A, B is equal to M, A also, but C. M, A, B means y2 minus y1, 5 minus 3, which is 2, divided by k minus 0, which is k, is equal to 2k minus 3, 2k minus 3 over 10 minus 0, which is 10. Making cross multiplication, we can write 2k times k to be 2k squared, and then minus 3 times k to be minus 3k, equals to 20. Rearrange 2k squared minus 3k minus 20 equals 0, so either k equals 4 or k equals negative 5 over